Hey guys, Mr. Decker here. This is Unit 3, Lesson 24. Today we're talking about functions. Functions are a big part of organizing our code and simplifying our code and making code easier to understand. So let's take a look at our standards for this lesson. It all funders, don't you know? It all falls under when you try to connect two words like fall and under, you get funder. I made a new word. There we go. All of these standards fall under algorithms and programming. We're going to be creating clearly named variables that represent different data types and perform operations on their values. And we really will be creating some variables in this one. We're going to be designing and iteratively developing programs that combine control structures, including nested loops and compound conditionals. We're going to be decomposing problems and subproblems in two parts to facilitate design, implementation, and review of programs. That's a big one. We're going to create procedures with parameters to organize code and make it easier to reuse, incorporate existing code, media, and libraries into original programs, and give attribution. We're going to systematically test and refine programs using a range of test cases. And we're going to document programs in order to make them easier to follow, test, and debug. All right. The essential question for this lesson: how can programmers use functions to create their own abstractions? If you remember from earlier in this unit, we talked about abstractions, how the velocity block is an abstraction, how the collision block is an abstraction. When you're checking to see if a sprite is touching another sprite, for instance, instead of having to do 6 separate Boolean expressions, you can narrow that down to one simple block. So abstractions, again, are just pieces of code that make much more complicated code very simple and easier to understand and easier to implement. Now, make sure you're answering that essential question back here on this page with at least 2 to 3 sentences in the text box entry. Let's jump over to code.org. I'm already looking at bubble 1 here. Let's look at our vocab. Our vocab is just one word this time. It's function, and a function is a named bit of programming instructions. And what a program is a set of algorithms, and a set of algorithms is basically a set of instructions for the computer to follow. So a function is a part of the programming that you've named, and we're going to learn the difference between a defined function and a called function. So let's continue. On bubble 2, we've got a video to watch, so join in.
There are 2 steps to using functions in JavaScript. First, we need to define our function, and then we need to call it. When you define a new function, you're simply giving a name to a defined set of actions you want the computer to perform. To call a function, you just type the name of the function, followed by parentheses. This is telling the computer to perform or execute the set of actions you gave a name to. You've already been calling functions when you use commands that end with parentheses. The only difference is someone else defined them for you. So let's walk through an example together. Notice that the toolbox now has a tab called Functions. There are 2 blocks in there, one for defining a new function and one for calling a function. Drag a new function block out and type in the name you want to give the function. Now add the code you want to run when the function is called. We'll add a fill command to set red, a no stroke to remove the outer line, and an ellipse command set to a random X and Y position. Hey, we defined a function, but nothing happened. The reason is we forgot step 2. We need to call the function. To call the function, we drag out the other block in the Functions tab and add in the name of our function. Now that we have both defined and called our function, the code will actually run and the dot will appear. Defining a function simply gives a name to a block of code without actually running it. The definition can actually be written anywhere in your program. The rest of the code will run line by line, just as before. Calling a function runs the lines of code inside the function. Afterwards, the program returns to where it left off when the function call was made. The fact that function definitions can be placed anywhere means that your code can get messy and hard to read. We typically put function definitions at the end of our programs to help keep things organized. You may have noticed that there's one function you've been defining, but not calling, in every program you've written so far. The draw function is a special function that you, as the programmer, get to define, but that GameLab actually takes care of calling for you. By calling wherever you've defined as the draw function over and over 30 times a second, GameLab is able to string lots of still images into a smooth animation. Once you have written a procedure or function that you know works as intended, you can call the function as often as you wish without worrying about the details or problems you had to solve to get it working. By referencing a large and complex block of code by a single name, it makes it much easier to understand what a program is doing by reading the code, and also easier to locate and fix problems or errors. Let's go ahead and dive in.
All right, excellent job, lady. You did a wonderful job explaining functions. All right, let me version history. I'm going to have to do that a few times through this. I already went through this lesson, but look at all these weird looking bubbles. Okay, continuing on. Let's turn all these bubbles dark green. Okay, calling functions. Functions let you build your own blocks and decide what code goes inside of them. This program has already created 2 functions, but only one of them is being called. Okay, interesting. Call the second function to reveal the full image. Use the function that is being called as a guide. So if I run it, right now I've got this little ellipse right here and the blue background. So we've got draw sky, background, RGB. So we're using RGBs. Remember that RGB works like this. There's a red value, a green value, and a blue value. As that number increases from 0 to 200 something, I forget exactly what the max number is, might be 255, then it saturates further with that color. So if I changed the red value to, let's say, 255, then that background is going to be more red than it was before. If I take the blue out of it entirely, then the only 2 colors being saturated here are red and green. Reset, right? And so let me Control Z all of that I just did, so we're back to the original color. So you can play around with these numbers to get different results over here for the color that you want. Let me make this bigger, bigger, bigger. That's as big as it gets, apparently. Okay. So now we've got these defined functions. They're defined by being given a name, right? And then having the code inside of it that tells that function what to do. Up here, I've called a function. So in my functions drawer, I have a define a function block and a call a function block. The call a function block is what I want to use when I'm telling the computer to use that code. If I leave these functions out here, get out of here, go away. There we go. If I leave these functions out here, it's giving the computer some instructions, but I haven't told the computer to execute those instructions, meaning to follow those instructions. I've just put something on the board in the classroom, and if the computer is my student, right, it's like, I don't know what to do. So I'm telling it what to do, or I'm telling it what to do with my define a function. I'm telling it to do it by calling the function. So, and to call it, you give it the same name as the define a function has. So draw sky, and I'm making sure that I'm using camel case here. Draw balloons. And just a reminder here that camel case means that the first letter of the second word in my name is capitalized. So now that I've called the draw balloons function right here, it's now performing that function. So when I define my function, I'm telling it what to do. When I call the function, I'm telling it to do it. Let's finish this bubble and continue. Bubble 4, reordering code. Placing code inside functions makes it easy to read and make changes to. Good names for functions indicate what your program is doing to a reader. You can call your functions in a different order to quickly make significant changes to how your program runs. So while this function is defined and it's the name of this function is draw background, I could call this function Steve, right? And it would still do everything that's inside here the same way it's doing currently, right? It's not going to change what it does with its naming convention, but naming conventions are important because in programming, most of the time, you're not the only person working on a particular project. In the event that you're making a video game with another team of people, sometimes hundreds, sometimes thousands of other people working on a large AAA video game, then, you know, the little section of code that is yours, that you're working on, other people are going to be logged into the same system working on that code as well. And if you don't use proper naming conventions, meaning, say, like when I'm putting the background into my game, if I call it Steve, then, you know, my coworker at the game development company is not going to have any idea whatsoever what I'm trying to accomplish there. They're going to look at this function called Steve and go, oh man, what does this even do, right? How do I fix this? I don't know what their objective even was in the first place. So, but if you call it something like draw background, then your coworker knows exactly what you're trying to accomplish there. They can fix any bugs or any problems that may occur. So it's always important to have naming conventions, and also for yourself, if you know, because in this instance, right, you're doing this code on your own. So when you're naming your functions, just go ahead and commit to best practice, right? Best practice is to give the function a name that makes sense and somewhat defines what is being accomplished there. So when drawing a background, tell me that you're drawing a background. When you're drawing trees, tell me you're drawing trees. When you're drawing clouds, when you are making your character's movement work, going up, down, left, right, so on and so forth, then define it that way. Name it that way. It's also going to help me when I'm debugging your games. So make sure we are on the same page with that. This program has already created 4 functions that draw parts of a scene. Unfortunately, it's not coming out right. All right, so we can see our 4 functions. We've got draw background, draw trees, draw clouds, draw fence. So those are our 4 functions. And then let me move this up. There we go. All right, so we've read the 4 functions to know what they do. We know what they do because of that naming, right? We didn't have to dig deep into the code and go, oh, what is this? Okay, the stroke is white, the stroke weight is 5. Line, oh my goodness, look at all these lines being drawn, right? Oh, look at all these rectangles being drawn. Oh, regular polygons being drawn. Oh, you know, so on and so forth. All right, and then call the functions in an order that draws the scene in a way that looks best to you. So let's go to our functions drawer, and let's go ahead and pull 4 call function blocks out here. and we'll put them all at the top and leave our defined functions down here, function definitions. So our first one, draw background, usually is the first thing we want the computer to do, right? So there's that, run it. Okay, I get this error because, right, these have not been called or defined, right? So let's make sure these match up. So let's draw trees here. Let's just put them in the order that they show up, and then we'll work from there. So now we've got draw clouds, and we have draw fence. So let's reset run. All right, so maybe it's a really foggy day and the clouds have settled down into the mountains and they're in the trees and obscuring our view. And while that does happen locally, let's move some things around here. So if I put background down here at the bottom, how will this look? Oh, whoops. So just like with any other code that we put in here, it draws everything in order. The order of the function definitions does not matter. The order of where you call that function does matter, because this is where the computer is executing the code. This is where you're saying, okay, now draw the trees. All right, now draw the clouds. Okay, now draw the fence. Now draw the background. So it's doing all of this in order from top to bottom. Again, it doesn't matter where you define the functions, right? This order doesn't matter as much as where you call the function. Okay, so let's pull draw clouds down here and reset run. Okay, now our clouds are showing up on top of the background. That's what we want. And let's draw the fence. Okay, cool. Now our fence is there. And then let's draw the trees. Perfect. All right. Or, you know, depending on what you like, you might like your fence in front of the trees. Maybe now this is like defining where a park is or something like that, right? Just, it's up to you. Finish. Continue. All right, bubble 5. Does it matter where you create functions? Well, let's talk about that. So for all your functions, so far, all your functions have been created at the bottom of your code. What do you think will happen if you call a function before it's defined? Notice that the red square is drawn before its function is created, while the green square is drawn after its function is created. Which of these do you think will be drawn? Okay, so let's look at our options here. But first, let's look at the code. So we've got draw red, so we're calling a function here. We've got draw green, we're calling that function down here. So in this draw red, fill red, make a rectangle. Okay, and remember that width and height, or height and width and height, I think, right? And then this is X and Y. So this is determining where it's going to be. So if I turn my grid on, I can see 100, 100 is right here. So one of my squares is going to be up here. And then the other one, the green one, is going to be at 300, 300 down here. So the green one's going to be here. The red one's going to be up here. But we've got a weird order going on. So we're calling the draw red function here. We're calling the draw green function here. Our options. A, the red square will be drawn, but the green one will not. You cannot call functions after they are created. The green square will be drawn, but the red one will not. You cannot call functions before they are created. Okay. C, both squares will be drawn. You can create functions anywhere you like in your code. Or D, neither square will be drawn. There's an error in the code. Well, I think I spoke a little bit about this on the last bubble, on bubble 4, that it doesn't matter where you put your function definitions. It does matter where you put your function or your call functions, right? When you're calling your function, that order does matter. But because our green one is going to be down here and our red one's going to be up here, they're not going to be overlapping in any way, so it's going to draw both of them on the screen. There you go. Now you see it. All right, bubble 6. Ooh, okay, good. We've got some activities to do here. Let's do all of them, A through D, and it looks like A through C, at least, are all related to each other. So I bet those will build on each other. So let's see. Let's go. Let's see what's happening. All right. Oh, wow. All right. We've got a flyman or a flybot, either way. Let's see what he's called over here. Animation flyman fly. All right. Calling functions in the draw loop. You can call a function inside the draw loop just as you would anywhere else in your code. Do this. A function that will draw a background has been created for you. We can see that here. A sprite has been created to move across the background. We can see that here. And he's already apparently been given a velocity, which is moving him from right to left. It's moving him from right to left because it's given a -1 velocity on x. Remember that x moves it left and right, y moves it up and down. And the reason right now that he's just leaving this trail behind him is because he's being drawn over and over and over again at a rate of 30 times a second. But we can see every iteration of its drawing because we're not drawing a background inside that draw loop. So we need to call the function inside the draw loop. So if we go into functions, grab a call a function, and make sure it is above draw sprites in that draw loop. We're going to call it trees background to match the label for the function as a definition down here. And now he's moving across the screen and the background is being drawn behind him over and over again, just as he's being drawn in the next position over and over again. All right. Now, if I were to put that there, now I can't see my sprite anymore, right? It's being drawn, but it's being drawn behind the background. It's important to put things where they need to be so that the computer draws things in the order you want them to be drawn. All right, let's head on over to part B of this, calling functions multiple times. Make the flyer reappear on the right side when it goes off the left. Okay, cool. We can do that. We've done that before. Calling functions multiple times. You'll often want to use the same code at many places in your program. Once you've created a function, you can call it as many times as you like. Do this. This code creates a sprite that moves across the screen once. Let's run it. All right, have I, oh, wait, I got a version history of this. There we go. So now when I run it, this is the original program, right? So this code creates a sprite that moves across the screen once. How can you make it go back across the screen? Note, the function is already called once at the beginning of your program. So we see that here. So that's setting the flyer where? At x450, so right off the screen there. Right over here is 450. Yep. At y200, that's what's putting him right there in the center, going this way on this plane. And then he's given a velocity x of -1, which makes him slowly creep across. Okay. All right, read the condition of the if statement inside the draw loop. So let's see. If flyer's x location is less than -50, meaning that he's over here off the edge on the left side, then we want set flyer to be ran again, I believe. Why do you think it's there? So this is checking to see if his location is here. So if we want him to go back over here, then we can use this set flyer function again. We don't have to put all of this code in here. We don't have to rewrite all that. All we have to do is call it again, set flyer. So that's the abstraction, right? It's simplifying what we need to do later because we've already defined where we want it to be set and what we want its velocity to be when it's set. To make it, let's make it go faster so that our testing works a little faster, but it should, once it gets over here, reset back over here, and it does. So testing speed, good. There's an itty bitty little sun up there. All right, this flyman looks so angry. What's he angry about? All right, I think we've done it. All right, continue. We're on part C now, making changes to functions. So this says making changes to functions. A nice benefit of using functions to remove repeated code is that you can now easily make changes to multiple places in your code. Just change how you create the functions, and your program will now use the new code everywhere your function is called. Do this. Make changes to the setFlyer function so that the flyer starts at a random Y location. Okay. Random Y location. So flyer.y gets, right? So let's go to math. And between 0 and 400. So we'll set that. So that means he's going to show up at a random spot going up or down. Let's make sure that's working. And see, we didn't have to do anything here because this has to follow the rules as defined in this function. Okay, so that's working. And let's make it move at a random velocity every time it's reset. So down here we have velocity. So let's replace that with a random number, and let's say -5 to -15. Run it. And so it should be a different speed each time, and looks like that's working. So every time it resets, it's at a different Y location, and its speed is different, or its velocity is different. Very cool. All right. So let's finish and continue. All right, now creating functions to organize code. All right, we're on part D. Creating functions to organize code. In GameLab, all the action is happening in the draw loop, but too much complex code makes it really confusing to read. To keep your draw loop easy to read, use functions for larger chunks of code. You can call them inside the draw loop and define them below. This is a really good example of using abstraction to think about problems at a high level and worry about details later. All right. Do this. This program should draw a daytime scene or a nighttime scene depending on the location of the mouse. All right. So, let me version history this. So if I run it, right now it's not working the way it's supposed to. Looks like we need to make a nighttime scene. So depending on the location of the mouse, it should be becoming a nighttime scene. All right. The draw loop describes what needs to happen, but one of the functions hasn't been written yet. So right now we've got draw day. We need to draw night. We've got an if statement in our draw loop that's checking the location of the mouse on Y. So that means it's checking where it is going up and down. So mouse Y greater than 200. So if it's greater than 200, it'll draw the night sky. So down here, it'll draw the night sky. Up here, it's going to draw the day sky. Okay, gotcha. So now we need to define draw night. Draw day is defined, so it's showing up the way it's supposed to. So let's define night. So I'm going to go ahead and grab all of this code that's here by highlighting it, Control C, And then I'm going to move my cursor with my up arrow key. You can also move it with the down arrow key, and you see that little black smudge moving around. So down, up, right, and when it's right there, I'm going to Control V. Now it's going to draw the same thing no matter where my mouse is, because both of draw night and draw day have the same exact code in them. So now we need to fix that. So let's go through and fix these definition or these RGB colors here. So sun, we're going to change that to moon, because night, the moon is in the sky, right? So let's make sure that will be the case here. So first thing I want to fix here is the RGB of the sky. Now, again, red, green, blue. I want this to be more blue than it is anything else. I don't want any red in my sky at night, and I don't want any green in my sky at night. I just want it to be blue. Let's see what that looks like. Not quite dark enough for the nighttime. So let's see if we lower that saturation to like 200, see what it looks like. Not dark enough still. Let's try 150. Oh, I think that is an exact match for the water blue. So we want it to be darker than that. So let's see what 100 looks like. Okay, let's go even darker. Let's try 50. Very good. I like that. Now my water, let's see. Can I just leave it at 0, 0? Let's make the water a little darker because it doesn't have the sun reflecting on it. So it's going to still be very blue, but not as blue. So let's go with 100 for the, yeah, that looks good. So the water's set, and let's change the sun to a moon. So RGB here, let's see. For the moon, how can I get this to be white? Maybe just like the same amount of color on each one will end up making it white. Ooh, it makes it like a grayish color. That's perfect, even better. So 200, 200, 200 gets this gray color. And then that's also, because this is the last fill here, it's also filling the color for all of these ellipses, which is this reflection. So when I first saw this, I was like, what the heck? Why are the stars down here and not up here at nighttime? But I realized that this is meant to be like the water, or the kind of shimmery reflection of the sun on the water, and then the shimmery reflection of the moon on the water. It's not perfect, but it works. Okay, so that works well. You can also, if you want to, go to HTML color names, open up that new tab, go here. And if you're like, I don't want to mess with all this RGB business, and honestly, I wouldn't blame you if you didn't want to, you can go here to HTML color names, and these are the names of all the colors that Code.org's Web Lab, their App Lab, and their Game Lab all accept. So if you put in a name of this, so let's do like Ghost White for the moon, just to give you an example. So if I take this fill out, right, reset run, see now this fill for the water is now, my water and my moon are the same color, and you can't even see these ellipses that are making the reflection in the water anymore because it's all the same color. The last color that you tell something to be is what's going to change the color for everything below it. So, oh, just a second. And we're back. Okay, sorry about that. Helping out with some projectors around the school. So, yeah, when you're the tech guy, where were we? Okay, yeah, we're changing the moon color. So if I go into drawing and grab fill color, if I leave that at yellow, right, it's going to be yellow. But I saw that one, what was it, Ghost White, that I really liked. So if I put Ghost White, let me click back in there so I can type. So if I type Ghost White here, that's the color it will use. So keep in mind, you can use these over here on HTML color names at w3schools.com. All of those color definitions work for these fills. So let me Control Z all the way back to my RGB. I like that a lot. Okay, so let's finish there. Continue. We're now moving on, it looks like, to bubble 7. So bubble 7, it says, using functions, what are 3 ways that functions can be useful when you're writing programs? Hint, go back to the practice levels for review if you're not sure. Well, what are 3 ways that functions can be useful when you're writing programs? Well, A, they can simplify your code. B, they can make your code easier to debug and easier to understand. 3, they organize your code. So you can type that out here and move right along to bubble 8. Write your own function. Time to practice writing functions of your own. This is a very simple game in which coins fall from the sky and the bunny tries to catch them. All you need to do is write the function that sets up the coin. I think I might have already... Yeah, it still remembers me doing this earlier. So let me version history mine. I think at the beginning, you can move the bunny back and forth, left to right. You can't move them up and down. The score is kind of broken and the coin is broken. So let's make this game work. Time to practice writing functions of your own. This is a very simple game in which the coins fall from the sky and the bunny tries to catch them. All you need to do is write the function that sets up the coin. So we're going to be working on this from bubble 8 to bubble 10. And then we have one challenge to do on bubble 11. So let's do it. Read and run the code that already exists to make sure you know how it works. So let's see. We've got coin create sprite at 210. So when I run it, there it is at 210. 200x, 10y. And then that coin is set to the animation as it's defined over here on the animation tab. And then we have the bunny at 200, 350. When we run, he's at 200, 350. And he's set to this right here. We have a variable for the score setup equaling 0. And you can see the score up here. And it is being drawn on the screen down here from line 25 to 26. So we've got text size 20, right? So that's making that text be 20 pixels tall. And we have what we're wanting to appear on the screen in quotation marks plus score. That's putting that 0 out here. And then 10, 10. So it's at 10x, 10y is what's its starting position, and then it's read out from there. And 100, 100 for the size, the width and height of it. That's interesting. Okay. So the rest of it, we've got if key down left, making the bunny go left. If key down right, making the bunny go, whoop, it thinks my cursor is over here. If I key down right, the bunny goes right. If I key down left, the bunny goes left. You can see that code from line 13 to 19. And I have code already set up to say if coin.y is greater than 400, meaning it's down here at the bottom of our display area, then it sets the coin. But our set coin function is blank right now, so it's not doing anything. Also, our coin doesn't have a velocity on y, making it go down yet. Okay, so it says write the code for the set coin function to do the following. Set the coin's velocity to move down. All right, and it's already called up here. So when we set the velocity in this function, at the beginning of the game, it's going to run what we put inside set coin at the beginning of the game, because we've told it to, up here outside the draw loop. Okay, and then down here, it's going to do whatever we tell it to in our function definition right here, where it's called in this if statement, or this conditional, where it's checking its location down here. All right. So the first thing we want to do is set the coin's velocity to move down. So sprites, sprite velocity y, coin.velocity y, because that's the name of this sprite, gets, let's see, y we need to increase. So we're going to give it a velocity of 5 just to get started. So run it. There it goes. Okay. And then set the coin's y position to the top of the screen. So we need to go sprite.y, coin.y gets, let's see, at the top of the screen, let's do it off the screen at 450. Or, sorry, negative 50 at the top. So run, and it should reset when it hits the bottom. You just keep going in that loop over and over and over again, because when this becomes true, it's going to set the coin running this code right here. Okay. Set coin's y position to the top of the screen, and then randomize the coin's x position. We can do that. So coin.x gets, and then we're going to go to math, random number, and we'll do 25 to 375. That way it doesn't ever go off the screen or halfway off the screen. So now, right, we want our bunny to kind of get to it and catch it wherever it may appear. Okay. So let's finish there and continue. Bubble 9. Catch the coin and increase the score. Let's make that score change now to complete the game. You'll need to be able to tell when the bunny is touching the coin and then reset it. All right, do this. Use an if statement and the is touching block to increase the score when the bunny catches the coin. So let's put an if statement inside our draw loop. So drawing, oh, not yet, control drawer. If statement, we'll put it there. Checking if the bunny is touching the coin. Okay, so sprites. Sprite is touching target. Bunny is touching coin. Then we're going to do set coin. Make sure you're using camel case, so that coin part of that should be capitalized. So touch, and it's resetting each time they touch. Awesome. And it's still doing that random location on X. Awesome, it's working. Okay. So now you're seeing where and how functions are imported in your code. I don't have to put this part of my code into these over and over and over again. I can define it, what I want to happen here, and then call it over and over again as many times as I need it in as many places as I need it. And make sure you're calling your function to reset the coin once it's been caught. And then play the game and randomize the velocity of the coin to a range that you think is fun. Okay. So let's randomize the velocity. So we can do that inside of our set coin function definition. So back into math, random number. So we'll set the velocity between 5 and, what do you think, 12? Let's see what that does. And I haven't changed the speed of my bunny. So, all right, cool. Oh yeah, that one was fast. All right, I like that. Okay, increase the score. Let's make change now. Okay, it didn't tell me anything about, log to increase the score when the bunny catches the coin. I didn't do that yet. So in that if statement, where did I put it? If bunny is touching coin, set coin. So I want to, let's see, variables, this one. So when you're creating a variable, right, the variable score gets 0. So at the beginning of the game, before anything is started, my score starts at 0. That's this block. So that's when you're defining or declaring a variable. When I'm assigning a variable, right, I want to use this one. So in that if statement, let's see, in that if statement, where did it go? There it is. I can say score equals math score plus 1. And I use score, the word score, because that's what I named my variable up here. So now it knows, okay, so that variable that was equal to 0 earlier at the beginning of the game, you're wanting to add to it every time the bunny touches the coin. So run, and you should see that score go up as I catch a coin. If I can catch them, there we go. Oh man, that bunny being that slow really adds to the challenge. Okay, cool. So finish, continue. And just a second, guys, I'm getting a phone call. All right, we're back. Sorry about that. Okay. So let's look here. Where were we? I got lost in that phone call. So let's see. We're using an if statement and 2 separate functions to draw backgrounds. Okay, I think we just started this bubble, right? So as of right now, we've got the score working, the reset working. Bunny can move left and right. Okay. Once you've caught 10 coins, it's time to celebrate. You should change the background to be something fun. All right, we'll do this quickly. Do this. Use an if statement and 2 separate functions to draw your backgrounds. All right, so we're going to throw an if statement in, but first, let's create these 2 functions. So we've got to define these functions first before we can call them. So I'm going to have a beginning background like that, and a when background. I want to show you something too. If I just leave it as background, the computer doesn't like this. So always use some kind of beginning background, when background, big background, red background, cool background, space background, something like that, because for whatever reason, this game engine really, really despises the word background by itself. Okay, so when background. Okay, so my beginning background, I'm just going to grab this and pull it down here. And then my when background is going to be, let's just make it pink. And then I'm going to put some text in it. We'll say you win. And I want to put that at, let's see, like 175x and 200, like 175y. And then I'm going to make the text size like 40. All right, and then I need to create my if statement. So control, and it's going to be an if else. So if math scores less than, if my score is less than 10, then we need to call our functions here. If it's less than 10, then it runs my beginning background. If it's more than 10, when background. So let's see if that works. So I put the functions in the right spots. I know that. Let's get to 10 here as quickly as possible to make sure that our when background is working. Okay, cool. It does work. 1 second, guys. We're ready for the next bubble. But we got to pause again. Okay, all right. Hopefully that was the last interruption because we're almost finished. Okay, so on the challenges for this function lesson, we're just going to do A. I never really require you to do B, but I always want you to do all of the challenges that are not the free play. So let's jump in here. Creating functions to draw scenes. The provided code draws one of two different scenes based on where the mouse is on the screen. It either calls the drawScene1 function or the drawScene2 function. However, these functions don't exist yet, so their definitions aren't there yet. So while we're calling them, there's nothing down here for them to be told what to do. So when we run this, it does literally nothing. Feel free to be creative and draw whatever two scenes you want. Do this, create the drawScene1 and drawScene2 functions and fill them with code to draw two different scenes. So, okay. All right, so we are going to define these functions here. So we need a drawScene1 and a drawScene2. So on this first one, draw scene 1, making sure I capitalize that S to match, and draw scene 2. And it's checking if my mouse is, its Y position is greater than 200. So if it's down here, it'll draw scene 1. If it's up here, it draws scene 2, I guess. Okay, so let's make some backgrounds. So drawing drawer is where we'll spend a lot of our time. And then we're going to have to set up some variables since we're moving shapes and not moving sprites. And so this will be a valuable tool. This will be an interesting part of our curriculum where you can come back to it later. In case you're wanting text to move around, I think we've done that earlier in another lesson. And then this one will teach you how to use variables to get your shapes to move around the screen. So this will actually be pretty beneficial to us, I think. Okay, so for drawScene1, let's see, it makes the background sky blue. So I'm just going to try to recreate some amalgamation of this instead of come up with my own plan, just to show you how this stuff works. So background will make sky blue. So run. All right, that's working. And for drawScene2, we're going to make the background color black. So run. Okay. So that's working. And then let's see, let's focus on draw scene 1 first. So I'm going to go ahead and grab a no stroke so that none of my shapes have a border around them. I'm going to make that sun. Okay, so he's going to start over here. So with the sun, we need an ellipse. And I'm going to put it at like x25 and y 100. And then for size, I'm going to make it 100, 100. Let's see. Run. All right, now I need to give it its color. Oh, whoops. Fill color is what I want. Not stroke color, but fill color. Yellow, reset, run. There we go. Okay. And then let's see. And I think there's something down at the bottom. Yeah, there's like a planet. Okay. So we're going to make another ellipse. And we're going to fill that with a different color. We'll make it green. And grab another ellipse block. And this time we're putting it down here and making it really big. So I'll leave it at 400, 400, but I want its X to be 200, but its Y to be like 450. Reset, run. Okay, its Y needs to be even lower, so let's do like 500. Reset, run. Let's go even lower, 550. And then let's make it way bigger. So width, let's make it like 600. Reset, run. That'll work. So now we've got kind of a planet surface down here, and I'm actually going to bring it back up to 500 now. That'll work. Okay, so now I want to make that sun move across the screen. So to do that, I need to set up a variable, define that variable, variable sun x, and then we'll say equals 25. And then we're going to use this. Oh, what inside the draw loop rather. And we're going to say sun x gets, and we'll do math. Oh, we don't have addition, so we'll have to type this out. So this is a good lesson as well. So sun x gets sun x space plus space. Let's say 3. Enter. And then down here for x on our sun ellipse, we're attributing that to it. So reset, run. And there it goes. It's moving. All right, so we've got that working. And now we need to do our night scene. So for this one, I'm going to copy this, Control C, well, without the sky blue, Control C, and then get my cursor down here, Control V, reset. And now this I'm going to make, let's see, what was my gray for the, let's do Gainsborough. That looks like kind of a moony color. And then let's make the planet kind of a dark green somewhere. Dark olive green, that should work. Dark olive green. And then if we run it, awesome. That's pretty cool, right? And then reset, run. I like that a lot. Really cool. Okay, so let's finish, continue, and that's the end of our functions lesson. I hope you really enjoyed it. Sorry about all the interruptions. When you are the tech guy in the school, people need your help, so there it is. Hope you guys are having a great week.